Okay, so here's an optimization problem. An oil company has a refinery at a point A on the bank of a straight river 1 kilometer wide. So I have a river that is 1 kilometer wide. And it's going to run a pipe from point A to point P, somewhere on the opposite side of the river. Okay, so we have here point A. Okay, and point P, which is going to be somewhere down the river. And then straight along the river to a tank situated 3 kilometers downstream. So I have about 3 kilometers here. Let's say something like this. I have a tank T. And then you're going to run a pipe until a certain point P here. There you go. Okay, so the pipe basically goes like this. That's the pipe. So one part underwater and one part along the underground, along the riverbank. Okay. It costs, so what are the dimensions here? So this is 1 kilometer. This whole thing is 3 kilometers, so let's call this X. And of course, this will be 3 minus X. Okay, it costs $15,000 per kilometer to run the pipe underwater, so $15,000 here per kilometer. And from P to T, along the bank, is $9,000. What should be the distance from P to T in order to minimize the total cost? Okay, so it's not so difficult. This distance here is square root of x2 plus 1. Okay, and so the total cost will be, so 15 times this. Plus 9,000 times this. Okay, we're good? All right. And what are the values of x? Well, x could be at most 3 and at minimum 0. There you go. So my problem is just to minimize c on this interval. Okay, so it's pretty simple problem. Okay, so we need to find the critical numbers.
Sir?
Yeah.
Would it have worked if the x was between P and T?
Yeah, it would work, of course. It's just that you would have a more complicated expression here.
Yeah, okay, thank you.
But it's true, you're right. Okay, so let's go. Let's find the critical numbers. So C prime is equal to the derivative here is going to be 15x over square root of x2 plus 1 plus, well, negative 9. Okay, so 9 times minus 1, and this has to equal to 0.
Sir,
Yeah,
is why it's not 15x divided 2 times square root x2
yeah,
plus 1?
because there's supposed to be a 2 here, but the derivative of x2 is 2x. So I cross.
Oh, okay.
Okay,
Oh.
okay, so I'm going a bit faster in the derivatives because I'm assuming you're getting this. Okay, so this has to be 0. So now let's solve for x. So 15x is equal to 9 times the square root of x2 plus 1. I'm going to square both sides. Okay, so right away here, you have to be careful. When you have a square root is equal to something with x, so right away you should have a restriction that x should be positive, right? You cannot have a square root equals to a negative, so x has to be positive here. Okay, so you would need to put a restriction here. But anyways, x is between 0 and 3, so we don't have an issue. Okay? And now I'm going to square both sides. So 225 times x2 is 81 times x2 plus 1. And so this is 144 x2 is equal to 81. And therefore, x is equal to plus or minus 9 over 12, which is plus or minus 3 over 4. So 0.75. Okay, these are my two values of x. Of course, I'm only taking the positive one because I'm between 0 and 3. And so x is equal to 0.75. Okay, so this is since x is between 0 and 3. All right, so now we need to evaluate the cost at each of the values, right? At 0, at 3, and at 0.75. So C of 0, C of 0.75, and C of 3. Okay, so C of 0. So if x is 0, this becomes 15 plus 27. So it's $42,000. At 3, this is 0, and this is 9 plus 1 is 10, square root of 10 times 15. So 47.43. And then at 0.75, I get 39. So as you see, this is my minimum. Okay, so the minimum cost occurs when x is 0.75, which means that P and T are 3 minus 0.75, so 2.25 away. Okay, we're just going to put it here, the answer. The minimum cost occurs when P is 2.25 kilometers away from T. That's the answer. And it's the answer we have. All right, let's go. This is a related grid problem. Okay, so two sides, two sides of a triangle are 2 centimeter and 5 centimeter long respectively, and the angle between them is increasing at a rate of 1 half radian per second. So let me draw this. Okay. Okay, so this is 2, and this is 5, and that forms a triangle. And I have an angle here, theta. And you want to find the, what do we know? We know that d theta dt is equal to 1/2. That's the rate at which theta increases. Find the rate at which the area, so we're looking for dA dt when theta is pi/3. Okay, that's the problem. Is this clear? The setup is okay? All right, so we need an expression for the area. How will we find the area here? Well, the area is base times height over 2. So area is base times height over 2. The base is 5. What is the height? What's the height here, guys?
Using sine, we can find the height.
Very good. Okay, so the height will be 2 times the sine of theta, right? And so the area is equal to 5 times, so base times height, which is 2 sine theta, and then over 2. And so the area is equal to 5 times sine theta. That's the area. I have the relation between area and theta. I can now find the relation between the rates by doing the derivative. So dA dt is equal to 5 times the cosine of theta. Is that okay?
Times d theta
Thank you.
dt.
Thank you. Times d theta dt, very good. Okay, and now I'm going to, what do I know? So this I know, it's 1/2. Theta I know is pi/3, and I could find what that is now. Finish. Well, that's an easy question, I think. So dA dt, 5 times the cos of pi/3, which is 1/2, times d theta dt, which we said was 1/2. And so you get 5/4 centimeters squared per second, which corresponds to our answer that we had up here. Any questions? Let's go. There's another one.
Wait, sir, can you go back a second, please?
Next one. Okay, so this I think is an optimization problem. Okay, so a square piece of metal is to be made into an open topped box by cutting squares from its corners and folding up its sides. Okay, so here's the situation. So we have a so sort of a square. Okay, so we have a square piece of metal, and we're cutting off a square from each of the corners, and then we're going to cut it out and fold it along here, right, along here and here, fold, and we're going to form sort of a little box, an open top box like this. I don't know if you could see it, not a very good drawer. Whatever, something like this, okay? That's what's gonna happen. Questions? Okay, so what do we have? Let's see the dimensions. If the box must have a volume of 2 meters cubed, so the volume here, that's given to me, that the volume is 2 meters cubed. What should the dimension of the box be to minimize the area of the original square sheet? Okay, so what are the dimensions of the box? So let's say I'm cutting here X and X, and therefore this will become the height. Okay, and let's call this Y here, which is the base. Okay, X, 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 X. You understand what's going on here? Okay, so what is given to me is that the volume is 2, so xy squared equals 2. That's for sure. And we want to minimize what? Minimize the area of the original square sheet. So we want to minimize the area of this sheet, which is 2x plus y squared. Is that okay? No questions? All right. So in that case, from here, I see that x is 2 over y squared, which I'm going to replace in here. And so the area is 2 times x, which is 2 over y squared, plus y and all this squared. That's my area. I will simplify. It will be 4 over y2 plus y squared. Okay, what are the, so we want to minimize this, and y is, what are the possible values of y? Okay, well, y could be 0. Could it be, not including 0. And it could go to infinity. There's no limit on the y. Okay, nothing, nobody stops you from having an infinite sheet with a very, very thin height and making it a volume of 2 still. Okay, let's find the derivative here and see when is this 0. So the derivative here is 2 times 4 over y2 plus y times the derivative of the inside, which is negative 8 over y3 plus 1. And this has to be 0. Okay, that's a weird one.
Sir,
Yeah.
could you lower the page, please?
Oh, sorry. Okay, so this times this is equal to 0, which means that either 4 over y2 plus y is 0, or negative 8 over y3 plus 1 is equal to 0. Okay, so from here I'm going to have y, so negative y cubed is equal to 4, and that can't be because then y is negative. Okay, so y is negative cube root of 4, and this cannot be. And here I'm going to have 8, so 8 over y cubed equals 1, so y cubed is equal to 8, and so y is 2. Oh, this makes more sense. Okay, and if y is 2, replace the 2 here by y by 2, you get 2 over 4 is a half. And so this means that x is equal to 1/2. Okay, so I found my answer. Okay, I'm not done yet, but I found my answer. See, y is 2, so 2 by 2 by x, which is a half. So 2 by 2 by a half, which is what I found. So the only thing left to do now would be to, of course, check that this is actually a minimum. Okay, so to do that, we need to find the second derivative here. Okay, so I'm going to let you do it because I don't have space, but a prime prime of y equals 2 should give me a positive number. So positive number. Okay, so just verify. Okay, and so we have the minimum. So 2 meters by 2 meters by 1/2 meters is minimum area. Okay, of the sheet.
Sir.
Yeah.
Can you explain why the area is that formula? I'm not quite sure I understand.
This here?
The one in the top.
This?
Yes.
Yeah, because it's the area of this. Just move back a bit lower here. It's the area of this whole sheet.
Okay. Oh, okay.
2x.
I thought it was the.
Sorry?
I thought it was the area of the box.
No, just the area of the sheet. That's what I want. To minimize the area of the original square sheet. Okay? Questions? Okay. Next one. Paper cup is in the form of a shape of a cone, is in the shape of a cone with a height of 20 centimeters and a radius of 5 at the top. So let's draw it. Okay, so a radius here of 5 centimeters and a height of 20. And water is being poured in at 3 centimeter cube per second and fills the cup. So height here h, radius here r. Okay, so what's given to me is dv dt is 3. Okay, how fast is the water level rising? When the water is 2 centimeter deep, so we're looking for dh dt, the rate at which h changes when h is equal to 2. Okay, that's it. I think we've done the same. We did the same question. So relation between volume and height. So the volume of a cone is 1/3 pi r2h. Okay, so we need now to express everything in terms of h. So the relation between the radius and the height, r over 5 equals h over 20. Okay. So h over 20 is equal to r over 5, and therefore the radius is equal to h over 4. Questions? Okay, I'm going to replace the radius by h over 4 in here. And so the volume is 1/3 pi times radius, which is h over 4, squared times height, which means that the volume is 1/3, well, pi over 3 times h3 over 16. Okay, and now I could derive both sides with respect to time. So dv dt is going to be equal to pi over 3 times 3h2 over 16 times dh over dt. Okay, so dv dt is given, h is given, it's 2, and dh dt is what I'm looking for. All right, so 2 is equal to 4 over 16. No, sorry, 3, that's 3, by the way. 3 is equal to 4 over 16 times pi dh over dt. And so dh over dt will be 48 over 4 pi, which is 12 over pi. Okay, which is the correct answer. That's what's written above.